But let's talk about it in terms of not Faraday's law. Okay? If I grab a bar in a magnetic field and I start pulling it, what's going to happen?
Current.
Why?
You change the area.
It resists change.
There's no loop. There's no area change. What are you talking about, man? There's no.
A charge.
Now we're going to calculate by doing a loop in a second. But as I pull a bar left and right in this magnetic field, what's in a metal bar?
Electrons.
Electrons and protons, right?
Rings.
So electron and protons are, let's say you're a proton. Again, probably a bad example because the electrons move more. But we're just going to pretend like positive charges move. Positive charge, if I have a velocity this way, is going that way, is it not? Velocity, magnetic field, stick out your thumb, there's a force in this direction. So this bar starts to become positive on this end and negative on this side, which is voltage, right? It's potential difference. So if I'm dragging it along, as long as I keep dragging it along, I got voltage.
Velocity.
Yep, V, magnetic field, force in that direction.
Magnetic field is down.
Down, into the board, into the board.
So I have the force going up.
Yeah, right, so the force would be upwards.
Okay, I was just looking at this example.
Yes, probably because they're moving electrons down. I don't know. What's the example? I'll take a look. See. Yeah, negative charges would go down. Positive charges would go up. What really happens is electrons move down, right? Electrons start to pile up down here. That's what really happens in real life. But we talk about positive relative charge, so it's always this argument over which one you want to talk about today. So as this thing is pushed to the bar, you're going to have this potential difference. Now, that's a problem because I don't know how to calculate it. So this is the way you calculate. You pretend like you have a what?
Loop.
A loop. Okay, you pretend like you have a loop. And I'm sliding the bar along the wires. Okay, now if I slide the bar along the wires, what am I changing? I got voltage is equal to d dt of BA cosine theta. What am I changing? A, I'm changing A. B is going to be the same. The angle is going to be the same. The only thing I'm changing is my area. Now, let's look at area for a second. Let's call this length and this width. Okay, what's the area of this shape? Length times width. B dt, B cosine theta. And, am I really changing the length? Not at all. So this becomes BL cosine theta times the rate at which I'm changing the width. What do we call the rate at which I'm changing the width? Velocity, V. It's of how fast the bar is being pushed, right? So it's just V. So, now this is a formula you're going to love. You ready? Voltage is equal to, this is voltage, or potential difference, is equal to BL, oh yeah, V.
Can we just write the squiggly E for voltage?
Yes. That's why they usually do at this point, by the way. EMF, right? And this is the length of the bar.
Why should we look at that?
That's velocity.
Trying to
I'm trying to differentiate two V's.
Oh, okay.
Two V's, the same equation, always bad news, right? This is magnetic field. So it turns out if you run a bar through a magnetic field, even an airplane in a magnetic field, there's current that starts to flow towards one of the wings, which causes electrical discharge across things like sensitive electronics. This is actually a bigger problem than people think it is. People don't want to worry about that. Don't worry about it.
Are there just natural existing magnetic fields that we fly through?
The Earth is one big magnet, right? There's always a magnetic field up there. You're always flying through it. There's always just a microcurrent flowing from one end to starts to spread out. You get constant speed, it sits there, parks.
Is that where the center of
And then when you land, it comes back. What?
the center of the Earth is moving?
The center of the Earth is, yes.
Because it's just like the
Right. It has to do with the fact that the whole thing's moving, right? So there is a bunch of charged particles inside of the planet that's actually turning with it. And because it's already turning, they've already oriented north and south. We do know, by the way, that for reasons we don't completely understand, the Earth does what every 10,000 years? It flips. The whole entire magnet inside the core, all the electric charges that are currently going one way flip over and go the other way. We're not really sure why that is.
How long? Serious ramifications of that.
None. You can't even feel the magnetic field. Your compass would start working backwards. Other than that, there's almost none. I mean, really, the magnetic field of the Earth is tiny. It's teeny, teeny, tiny. So whenever you see a movie where it said the magnetic field flips and everybody dies and the birds start crashing into the ground, and the birds would be confused. They would try to be flying north-south thing. They may use magnetic fields to actually to figure out which way they're going. Sharks, we know, are sensitive to magnetic fields, so they'd be confused for a while. For 100 years or so, the sharks would be all confused or swimming the wrong way. But other than that, there's almost no effect at all. Okay, when it was happening, it might affect electronics.
Wait, what year is that going to happen?
We don't know.
What if it's
No
like
idea.
next year?
It could be.
That'd be cool.
We know that if you look at the magnetic field lines, whenever a volcano erupts at the bottom of the ocean, has these big, long mountain trenches where the things open up and there's more magma flowing out. That magma creates has iron in it, so it creates natural magnets that orient wherever the North Pole is at the time. We know every 10,000 years the magnetic field just switches because these bars, these directional bars, are pointed the other way. That's what we know.
Is there a point when they're like equal to each other?
It's very small if it is. Generally speaking, it flips pretty fast on a geological scale, which of course could be 50 years. We think it's probably faster than that. We think it flips over, it just rolls over. Whatever's going on, it rolls over. And the sharks are going to go swimming this way. Whoa! And then some birds that might be sensitive to it might actually, instead of flying north for the winter, start flying north for the winter and south for the summer and get confused and start dying in massive scales. But other than that, if you're not a bird or a shark or something, you probably don't care. Okay, so good. That's it. We're done. No more E&M for the rest of the year. Nothing new. Yes.
So what if Russia decides to launch a nuclear device